Now let's take a look at problem 1. Use the definition of the derivative to find the derivatives of the following functions. So we start with question A. Have this f of x equal to a parabola function, quadratic expression. So for the derivative, we always start with the limit expression. Limit h goes to 0, fx plus h minus f of x divided by h. Now we're gonna plug in this x plus h into this expression. So just replace the x with x plus h. Plus 3 is x plus h plus 2. This is my f of x plus h minus f of x divided by h. It's a complicated expression, but after we simplify the top, it shouldn't be too complicated. So we have now combine these two terms here. Combine these two terms, and also these two terms are cancelled. Now we have that for the green terms here as negative of, I should use this color, x plus h bracket square minus x squared plus 3 times x plus h minus x plus this 2 minus 2. Like that. Now we have this by the difference of square formula, that is a plus b times a minus b. So that is a plus b, that's 2x plus h. A minus b, that's h. Right? That's the difference of square formula. I mean, this is a squared, this is a b squared. Okay? And then the next term we have 3h, right, plus 0. And now we factor out the h and cancel that with the h in the bottom. So this h is gone, this h is gone, h is gone. This is negative 2x plus h plus 3. Now we have cancelled out the 0 factor. We can just plug in h equal to 0 in this expression. So we have negative 2x plus 3. That is our answer. And now we can use the rule to verify this answer by taking the derivative directly. By using the power rules, this is negative 2x plus 3. Right? Same as this expression here. So now we know that our answer is correct. So that is our question A. Now take a look at question B. Do it in the exact same way, starting with the limit expression. Limit h goes to 0, gx plus h minus gx divided by h. plugging in this into g of x plus h. Just replace x with x plus h. This one, okay, minus g of x, that is this one. And this altogether divided by h. Now we kind of group these terms together, and these terms together. Now we have 6x plus h minus 6x divided by h. And now we change this expression. Divided by h is same as multiplying with 1 over h. Now this becomes 6x plus h minus 6. This. Now we cannot do the cross multiply stuff to combine these two fractions. So it becomes x plus h, x here, 6x minus 6x plus h. Okay. And then we continue. So the 6x cancel, and we are left with minus 6x h, x plus h times x here. Now this h cancel with the h here. That's the 0 factor. Now we are left with negative 6 divided by x plus h times x. We can plug in, and that is negative 6 divided by x plus 0 times x, which is negative 6 divided by x squared. Okay? So we use the rule to find the derivative directly to verify our answer. That is the derivative of 6x negative 1 plus 2. Because for the reciprocal function, we can change that to x to the negative 1. And then followed by the parallel rule, this is 6, right? The exponent comes down here, negative 1, x negative 2. Derivative of 2 is 0 because 2 is a constant. So we have negative 6x negative 2, which can be written as negative 6 divided by x squared. Now we see that the expressions are the same, so our answer is correct. So that is our question B. Now move on to question C. This one here. And same thing, starting with that expression. H goes to 0. Px plus h minus p of x divided by h. So now we have 16 square root of x plus h plus 9 minus 16 x plus 9 divided by h. Okay, and we can factor out the negative the 16 here. So we have this minus this square root, and we are very familiar with handling square root. That is, we multiply the conjugate. Very familiar with the conjugate. So it's this guy plus 9 plus this that is called multiplying the conjugate. Okay, and then I make use of the difference of square formula to simplify the top. 16 here. So combining this top here, difference of square formula, as a minus b, a plus b. So it becomes a square, this thing square, minus b square. Square here. Over this h times, for the bottom here, we just leave them like that, not doing anything yet. And we simplify the top. So we have x plus h minus plus 9 minus x plus 9. Okay, now continue to simplify the top. We have 16 times h, because x plus 9s are cancelled. Okay, x plus 9 cancel. And the bottom we have this times, actually the same thing. Same thing here. And now we can cancel out the h's here. And now we are left with this expression. So we plug in 16 divided by x plus 0 plus 9, right? Substituting h with 0. There's x plus 9. So now we see that is 16 divided by x plus 9 square root plus x plus 9 square root. These things are the same, so it's twice of this thing. Right? And we can cancel out the 2, so we are left with this one. Okay. And we can also use the rule to verify our answer. Firstly, this one can be written as 16 times. Well, it requires something called the chain rule. Maybe you haven't covered this in class, so maybe we will do it next time because it uses something maybe you haven't learned. And if you've learned it, just check it yourself. It's not very complicated. So that is our question C. Okay, by definition, find the derivative. Yeah, it's very straightforward. Now move on to question 2 here. Find the derivative of the following functions. We basically just apply the rules. Right? For the first one, it's obvious. This 2 to the 40 is a constant. Right? This e is a constant, 7 pi is a constant, so this whole number is a constant. And we know that derivative of any constant is equal to 0, so it's 0. Even though it's a complicated number, but as long as it's a constant, its derivative is always a 0. Okay, so that is our question A. Question B here. We do the derivative term by term. You have lots of terms here, so it's like derivative of each single term combining together. So firstly, start with the first term here. This number goes down, this coefficient, and then minus 1. So 7 times 6x, 7 minus 1, that's 6. Okay? And for the second one, this thing goes down. So negative 1 times 3x, minus 1, that's minus 2. And for the log function, just remind you the formula. Log ax derivative, it's equal to 1 over x times 1 over ln of a. Okay, so you have this log5x, then this derivative is equal to 1 over x times 1 over 5, 1 over ln 5. Okay, and the next term here, okay, so it uses the chain rule, so I assume that you've covered the chain rule in class. So this one is a composition of two functions. The most outside function is the exponential function, and the inside function is x squared. So we're gonna multiply the derivative of each of these two layers. We're starting from the most outside function, that's the exponential function. We know that the derivative of this e to the x is e to the x itself. But now, the x has been replaced with the inside function x squared. So the derivative of the first layer is gonna be e to this x squared. Because you replaced x with x squared. And the second layer is gonna be the function x squared. So for this one, you imagine that you cross out this e, right? So you find the derivative of this function, x squared, which is 2x. Okay? And you multiply these two things together, that's the derivative of the entire function. E to the x squared times 2x. It's the chain rule. If you're still confused with that, I'll explain a little bit here. Let me finish this first. So the last term, that's pi to the 3, okay, is a constant, so it's 0. So that is the final solution. You can simplify it a little bit if you like, but it's not a big deal. Now let me explain this chain rule again in case you're still confused. So this function, I denoted that by y equal to e to the x squared. Okay? And then the inside function here, I'm gonna let it be u. So u is equal to x squared. Okay? So this way, I kind of break down this function into two functions, u equal to x squared and y equal to eu. The advantage of doing that is because we can make use of the formula for each single expression here. The y equal to e to the u, we have the formula in our formula sheet, and for the u equal to x squared, we can also make use of the formula. So now the chain rule says that dy divided by dx, that's the derivative of y with respect to x, right? It can be written as dy du times du dx. It's kind of inserting a variable u in between. And you can also imagine that these two du's, they got cancelled. So this is actually the expression dy over dx. Now let's compute this dy over du. For this one, you look at the expression between the relation between y and u. Y is equal to eu, so the derivative is just e to the u. Okay, and the second expression here, du dx, you take a look at the relation between u and x, this one, and its derivative is 2x. Okay. And since we want the final expression be written in terms of x only, so you're gonna substitute this u expression in here so that the variable u doesn't appear in the final answer. It's just acting like a bridge. So this becomes e to the x squared times 2x, same as the thing here. Okay, so that's the explanation of using the chain rule, in case you forgot. And that is our question B. Now let's take a look at this question C. It's a fraction. You can apply the quotient rule, but applying the quotient rule will be very complicated. So instead of doing that, we go the other way. That is, we simplify the function first. So now we have b squared plus 4b plus 3 divided by b to the 1 over 2, because the square root is essentially 1 over 2 in the power. And now we split these terms. So we have b to the 3 over 2, right? Just minus, subtracts the power. So this is 4 b to the 1 over 2 minus 3 times b to the negative 1 over 2. And apply the power rules to find the derivative of each term. This is 3 over 2, b to the 3 over 2 minus 1, plus 4, this times the 1 over 2 here, b to the 1 over 2 minus 1, minus 3 times this negative 1 over 2, this b negative 1 over 2 minus 1. And now we have b to the 1 over 2 plus 2 b to the negative 1 over 2 minus this becomes, oh, I did something wrong here. It should be plus here. Should be plus. Minus 3 over 2 b to the negative 3 over 2. So that is our final answer. So that's a lot easier than using the quotient rule. Okay, so that is our question 3. Question C. Now let's take a look at problem 3. Find the slope-intercept form of the equation of the tangent line of the graph f of x equal to x cubed minus 9x squared plus 15x at x equal to negative 1. We know what the slope-intercept form is. We need to find the slope and find the point to plug into the point-slope form. And later on, we convert the equation into the slope-intercept form. We also know that to find the slope, we need to find the derivative, because the derivative is the slope. So we find the derivative first. Derivative is 3x squared minus 18x plus 15. And we plug in negative 1 in here to find its derivative. So it's 3 negative 1 minus this negative 1, 15, which gives us 34. So now we know the slope is 34. Having the slope is not enough. We also need to have the point, right? Point. We have this, x equal to negative 1. So we plug in this into the original function to find its y coordinate. So this becomes negative 1, 3 minus that is equal to negative 1 minus 9 minus, which is negative 25. So now our point, negative 1, f negative 1, it's equal to negative 1, negative 25. Okay, so this is our point. Now we use the point slope form, y minus negative 25 equal to the slope 34, x minus negative 1, which gives us that y plus 25 is equal to 34 x plus 1. And then we have y equal to 34x plus 34 minus 25, which is y equal to 34x plus 9. That is our slope-intercept form of the equation of the line. And a summary here is that we use the slope to find the, use the derivative to find the slope, and use that given point, plug into the original function to find the point, x and y coordinates. And the last step is to use the point slope form to write out the equation, and then we convert that into the points, the slope intercept form. So that is our question 3. Moving on in the last question. Company's total revenue T months from now are given by this. So this is a function of the revenue in terms of T. Now find the marginal revenue function. We know that the margin revenue is the derivative of the revenue function. So we just simply take the derivative of this T, right? And then it's 0.015 times 4 T to the 3 plus 0.4 times 3 T to the square plus 3.4 times 2 T plus 10, which simplifies to 0.06 T to the 3 plus 1.2 T squared plus 6.8 T plus 10. Okay, so that is the marginal revenue. Very simple. Now question B, find R4 and R prime 4. How do you interpret these things? So find them first. R4 is equal to so I don't have a calculator here, so this is kind of difficult to compute them by hand. So I will leave them for yourselves. I will let you know how to interpret these. R4 is obviously the revenue 4 months from now. Right? So this is the revenue 4 months from now. And R prime 4 is the marginal revenue four months from now. Okay, so that is our question B.